So now that we've got the delta y for the first interval, we can do that the rate, it's really the velocity since we're considering it to be negative. It's speed if you consider it always to be positive. Speed is the absolute value of velocity or the magnitude of velocity. So we're dealing with a negative quantity, so we're dealing with velocity. Sometimes I use the words interchangeably, but I'm not supposed to. So, but if I call it rate, then I'm safe. The rate is delta y over delta t. We've just calculated the delta y is negative 18,135. And the delta t means the time interval here. So we can see that the time interval from 5 to 25, and really it's the t2 minus t1 that you have here, that delta t is equal to 20 seconds. All right, so that's over 20. So then going back to my calculator, I can just say, my result here divided by 20, and I get negative 906.75. So that's my velocity for the first interval. It's negative 906.75 meters per second. We'll put on the units. We're not always going to need units because it's math class. Nothing we talk about is real anyway. But to make our physics teachers happy, we'll always put the units on. Occasionally, the AP exam will ask for units, but not always. Part B, or Group B, Strategy B, was using 25 seconds to 45 seconds. So now what I want to do is really just sort of go over the calculator technique again and show how it's going to shine for us again. So I'm going to do y of 45. So another thing that I'm showing is sort of consistency in how I'm writing and organizing my work. That's something I want you to work on. If you're a person who is inherently organized, consistent with your work, that is great. If you are not, you need to get there, or you're not going to be able to do this stuff. I personally am inherently not organized, not consistent at all. I discipline myself to do that. And you have to. So now I want y of 45 and y of 25. Oh, well, y of 25 I already have. I have that up here. So 101,718.75. For y of 45, now look, I'm going to copy from my calculator again, but I'm not going to copy the y of 5 because it's only a one-digit number. I could, but I'd have to insert. So I'm going to go up to your y25 because that's a two-digit number, so then I can just change the 25 to 45. These are the kind of calculator techniques that will make your life easier and make the exam quicker for you. So I get 13,383.75. And those are, of course, meters. Oh, look how I left those units off. Don't tell Mr. Parker that I did that. All right, now I want to know, I'm just keeping consistent with my notation. I'm going to keep delta y, which is y of 45 minus y of 25. So I can calculate that. So see how it doesn't bother me to write that out a couple of times? That was something that another professor of mine said, don't be afraid to write the line over and over again. It keeps your work organized. It's not going to injure you at all. All right, so I need to do 45 minus 25. So here's my y of 45. So I'm going to hit enter and put that. Now I have my y of 25 way up here. I can just scroll up there to where y of 25 was, find the number, and press enter, and it nabs it and brings it down. But what did I forget to do? I forgot to put minus. So I'm going to delete all that. I want to be careful. If I hit clear, it might clear the whole line. That's what I'm worried about. It might clear the whole screen, and I'm going to lose everything. So I'm going to do delete. I think clear would clear my whole screen. I would lose all my intermediary results. So I'm going to try this again. Y of 45. This time I'm going to remember to hit the minus. That's what happens when you talk and work at the same time. Come up here to where my 125 is. Hit enter. Now I've got y of 45 minus y of 25. There's other ways to do that, but that's probably the quickest. So I get negative 88,335. 88,335. It's always a good idea to think about meanings as you go along because you can catch errors. So for example, I expect in that second 20-second interval, the distance to be a greater negative number. That is, it fell farther, and I see that is clearly the case. I expect that again because the object's accelerating. All right, so now just keeping consistency again, r equals delta y over delta t. So that's going to equal negative 88,335 over my time interval is still 20. But watch, because our third one, the time interval is going to be 10. 20, so I can just go, actually I don't even have to do anything. I just go divide by 20. And I get negative 4,416 0.75, again reinforcing my prediction that the second interval is going to give me a higher speed than the first interval. Okay, do I want to work out all the rest of the intervals? I think I'll just present the results of the next one in the next video.